Okay, class, so we're be going over section 2.4, in particular the part on bearing. Um, since we already covered these previous angle elevation and depression in the previous class, I'm not going to go over those right now. I will be posting the solutions for this. Okay. So one of the applications that we're going to go over is known as bearing of a line. And this is mainly used in navigating and surveying. So what does this exactly mean? What when they say bearing? Well, for this, we need to kind of think about a compass. So any compass, we put north, east, south, and west. So this in these problems, when we think about the bearing of a line, we consider angles in relation to the north and south line. And so each time, let's say they tell you that something is moving to a point with a bearing of north 32 degrees east. What that means is, okay, this is the northeast portion. So I need to make an angle of 32 degrees. So this is the direction something is moving in. Now the question is, okay, well, is it 32 degrees from here or from here? Well, in the case of bearing, we always do the notation or we measure the angle from north or south. Hence, it's going to be here. This is the 32 degrees. So northeast bearing of 30 degrees would look like this. If we had, let's say, south 32 degrees west, then again, north, east, south, west. I will be drawing it in this part between south and west. And the angle will be with the south line. Okay. So your angle of bearing is always with either north or with the south. You don't draw it with west, east, or west. Okay. So let's look at the next slide. Just erase these a little bit. Okay, so here we're given a couple of more examples. So for example, it says the bearing of B from A. This is also important, keeping track of where your bearing is starting from. Okay, so B from A means that you're starting from A and you're going towards B. So in each case, that's what we see. Also, again, notice that the lines are, the angles are either measured from south or they're measured from north. So this is very different from what we've been doing previously. We've been previously always measuring from the positive x-axis. In this case, these are not necessarily an XY axis. We're, again, thinking about a compass. And so our angles are in relation to a compass north-south line. Okay, so don't think about bearing problems as XY points. Rather, we're going to be thinking about a compass and its angles with the north-south line. Okay, let's move on to the next slide and look at actual problems. Here the space. Okay. So we're given this question. San Luis Obispo, California is 12 miles due north of Grover Beach. If Arroyo Grande is 4.6 miles due east of Grover Beach, what is the bearing of San Luis Obispo from Arroyo Grande? Okay, let's zoom in a little. So this picture, this problem is nice. It has a little picture already given, but let's see how this picture was constructed based on what's said to us. So first thing we're given is that the San Luis City is 12 miles due north of Grover Beach. So it's going to be Grover Beach is the starting point. And you have to go north of Grover Beach. So here's Grover Beach. And we're going 12 miles north. And we get to San Luis Obispo. So we have that. Okay. Now, what does the next part say? The next part says, if Arroyo Grande is 4.6 miles due east of Grover Beach. Okay. So again, starting point, Grover Beach, and you have to go east. The city would be east of it. So east is that way. Hence, Arroyo Grande is over here. Notice that this created a right triangle. And the question says, what is the bearing of St. Louis from Arroyo Grande? So from Arroyo Grande, this is where the bearing angle should start from. Start. And then this is the city of the where it ends. So the bearing angle, again, this is the north. If you draw the compass, this is the north axis. So here's our angle created by this line that connects the two cities. Now, in order to solve this problem, we're going to be using what's known as alternating angles. So just a refresher about alternating angles. Whenever you have two lines that are parallel, this is like a geometric review, and you draw a transversal, so a slanted line through them, then the angles that lie along this corner, these corners are known as alternating angles. So these two angles would be the same, and these two angles would be the same. So again, alternating angles, another way to remember them is if you have like a Z shape, then the corners of your Z shape form the alternating angles. Or if you have an N shape, then the corners of your N form the alternating angles, assuming again that these two sides are parallel. So over here, we see that this is parallel to this. So, and we have a transversal. So this angle has to be equal to that angle. So by using alternating angles, we have now this triangle. So to find this bearing, I just need to solve the angle here. Well, for this triangle, this is the opposite side. And then this would be the adjacent side. So which function connects the opposite and adjacent? It would be tangent. So tangent of theta, it has to be equal to 4.6 over 12. So now to find our bearing angle, we can take tan inverse. After I take tan inverse of this, again, we need to be in degree mode. I end up with 20.97 degrees. Okay. However, this isn't the final answer because again, we need to express this answer in bearing form. So how do we do that? We'll go back to our picture and we see that the angle that again that we're creating is this one is created with north towards the west. So the answer would be the bearing is north 20.97 degrees west. And that would be our bearing. Okay. Let's look at another example. But the next example won't have a picture, so we'll have to construct it ourselves. I'll just clean this up. Okay. So let's see this question. Let's construct the picture based on what's given. We are 18 miles due south of Nipomo. So the city Lompoc is 18 miles due south. So Nipomo would be our starting point. So let's say N for starting point. We go 18 miles due south. Then this is Lompoc, which is 18 miles. Okay. Then it says Bolton, California is due east of Lompoc. Okay, so now Lompoc is the starting point and we have to go east. It doesn't tell us how much east. It just, we know that's east. So, okay, let's say about here. And then it also says that the city of Bolton has a bearing of south 65 east with Nipomo. So let me draw a compass here. And again, from Nipomo, so the bearing's actually with the city of Nipomo. So north, south, east, and west. So the bearing has to be 65 southeast. So right here. And the angle is right here. Because it has to be with the south line. So we have this right angle triangle. So let's clean it up. We have basically this picture. Right angle triangle, 18 on this side. This is Nipomo. This is Lompoc. This is Bolton. How far is Lompoc from Bolton? So we need this distance. And we're given that this angle is 65 degrees. Okay, well, for this angle, this is the opposite side. Call this X. It's the opposite side, and then this the adjacent side. So again, we will have tangent of 65 equal to X over 18. Well, if I want X, multiply 18 on both sides, you get 18 times tangent of 65. Now I can put this in the calculator and I get 38.6 miles. So that's the distance between those two cities. Okay, so in these two examples, we were able to construct a right triangle very easily. Let's look at an example that has more than one bearing to it. Just cleaning up before I go to the next slide, because all these markings just end up on the next slide. So okay, example 4. Let's see what this says. A boat leaves the harbor. Actually, let's make a little bit of space for this problem. Okay. A boat leaves the harbor entrance and travels 25 miles in the direction of north 42 east. Okay. So let's say this is the harbor. Okay. And we are traveling northeast. So if I draw a compass, the northeast would be this way. Right, so the boat's traveling northeast and it travels for 25 miles. 25 miles. The captain then turns the boat 90 degrees and travels another 18 miles in the south 48 east bearing. Okay, so let's do this in a different color. So after 25 miles, again, north, east, south, west. Now we have to go south 48 east. So I'm going to make an angle here, like this. And it's saying this angle right here, that's making with the south axis is 48 degrees. 48 degrees. But the turn that I made was 90 degrees. So 90 degrees, so this full angle is 90 degrees. All right. Then it says, so now the boat's basically here at this point. This is where the boat is currently. And this distance that it traveled here was 18 miles. So how far is the boat from the entrance? So how far is it from the entrance, which was the harbor? So this is the distance we need. And let's just draw that compass again, because we're going to need that. So let's say this is the distance we need, which is X. We also want the bearing of the boat from the harbor entrance. So from harbor, that means the bearing should be from the harbor. So the harbor again is here. And this is going to be northeast. So the angle that we're looking for is this one. Okay. So all that angle data. Now, if you recall, in the beginning of this, it told us that the boat started traveling 42 degrees. So this first angle that was created, the bearing, just this tiny little portion right here. Oh, I don't want that. Yeah, the little portion right here, this one right here. This angle is 42 degrees based on the bearing. However, we need the full angle labeled in black. But if this tiny portion is 42, then this portion right here, this angle right here, would inside the triangle would have to be for theta minus 42. Right? Because the black angle is theta and the red angle is 42. So the portion that remains inside this has to be theta minus 42 degrees. Okay, that will be helpful because we can use that. We can use this to now determine the bearing. So first, let's find the distance x. Well, again, we have a right angle triangle here. So we can use Pythagorean theorem to find x, where x is the hypotenuse of our right angle triangle. We have 25 squared plus 18 squared equals x squared. So x would equal the square root of this. And this comes out to be 30.8 miles. Okay, so that's the distance of the boat from the harbor. Now we want to find again this angle. So this is going to be the opposite side of the angle, and this is the adjacent side. So we can do tangent of theta minus 42 equals 18 over 25. So if I do tan inverse, in degree mode, I end up with 35.75 degrees. Okay, but again, that's just this little part right here. But I actually want theta. Well, theta is so we actually found theta minus 42 is equal to that. So that means theta would be equal to 35.75 plus 42, which gives us an angle of 78 approximately. So I'm just rounding up. So finally, we need to write this in bearing form. We are in the northeast quadrant. So my bearing would be north 78 degrees east. So this was the distance, and this was the bearing from the harbor of the boat. Okay, let's do one last question for this chapter or section. So let's clean up. Okay. And yeah, so last slide. Now, again, this one we have to draw the picture. So start with black. A ship travels 2.3 miles in the direction of South 31 West. Okay. So compass. It's traveling 31 degrees, 2.3 miles. So the angle is 31 degrees over here. Turns 90 degrees. Okay, now notice if it turns 90 degrees, it could go that way or that way. So we don't know, and that's why we need to see the rest of the problem. It turns 90 degrees, goes 3.5 miles, north 59 west. Okay, so let's draw the compass. So if this is north, this would be west. So it has to go this way to create a bearing of 59 west. So this angle, let's draw it a little bit bigger. Yeah, this angle right here is 59. And this is 3.5 miles. The other thing is that the total angle is 90 degrees. So again, how far is the shift from the starting point? So this was the starting point. So this is what we have. So how far is that? Let's say this is X. And what is the bearing from the starting point? So the bearing this time is this angle. So theta is indicated in red. Okay, so let's find first X because again, we have a right triangle. So X squared has to equal 3.5 squared plus 2.3 squared using Pythagorean theorem. Okay, and what does this give us? 3.5 squared plus 2.3 squared, and then take the square root. So x is about 4.2 miles. Yeah, that's how far we're from the starting point. Now let's see how we can determine what data is. Okay, so again, data is the angle indicated in red. So if we subtract 31 from theta, then we have this portion right here inside the triangle. So the blue would indicate theta minus 31 degrees. That's here in blue. For this angle, the opposite side is here. The adjacent side is here. We know those lengths. So we get tangent of theta minus 31 is equal to 3.5 divided by 2.3. So theta minus 31 is equal to tan inverse of 3.5 over 2.3. Which, let's see, what does that equal? Okay, so this gives us an angle of 56.7 degrees. Okay, but we would need to find theta, so this is just theta minus 31. That means theta would be equal to 56.7 plus 31. And I'm rounding up to 88 degrees. So if we write this in bearing, oops, in bearing form, then again, we're in this area right here. So that's southwest. So south 88 west. That would be the bearing. And this was the distance. And then that is the end of section 2.3. And then these examples should help you solve the remainder of the last question in the chapter 2 lab. Okay. Just contact me if you have any questions.